All right, we're on our last section, 9.6, and now we're talking about trends in electron affinity. And kind of the same objectives we had, be able to define it, be able to describe the trends on the periodic table. So what are we talking about? Well, electron affinity, first of all, when an atom gains an electron, it gives off energy. It takes energy to, it gives off some energy when it absorbs an electron. That energy is known as electron affinity. Okay, so when it absorbs that electron, gives off the energy, that's its affinity, that's the electron affinity. So it says electron affinity is defined as the energy released when an atom is added to a gaseous atom, when an electron is added to a gaseous atom or ion. So we give off this energy, this atom gives off energy when it absorbs an electron. That's known as electron affinity. In general, and if as you looked at the ptable.com and looked at these, you'll notice that this trend is the most difficult one to kind of pick up. But in general, going down a group, the electron affinity generally decreases because the size of the atom. So if I'm always still drawing mine to bigger, it gets bigger as you go up. Here's smaller, decreases as you go down, gets bigger as you go up. Okay, why don't you write that to the side of your thing so you kind of remember that. Smaller at the bottom, gets bigger going up. And increases as you go from left to right. So here's the smaller, bigger. Also put that in your notes to the right here, or just around the slide. All right, so there are some exceptions here, especially when you're in the smaller atoms, like the ones in the second period, and probably due to those small electron clouds. And what happens when they're small, those electrons are kind of close together, there's a lot of repulsion, and so, it's going to change the amount of energy it takes to pull in that electron, and it doesn't really want to do it if there's going to be a lot of repulsion. It's like, think about bringing in a magnet that's going to repel another one. You got to put a lot of force in to do that, and that happens more in smaller atoms than in bigger ones. So especially in period 2, you see a lot of exceptions. Also, the noble gases, because they're full, they don't want to gain and create another electron, so they have no affinity for electrons at all. And so we kind of talked about this in the last one too, in electronegativity. They don't really have a desire to pull in an electron because they don't want to make a new level. Same thing here. Electron affinity, electronegativity, extremely similar. They're very, very similar. So really, one is how good it is at taking one. The other one is the energy required to do that, is kind of what it's talking about. So when an atom becomes an ion, it's either going to release energy, which is electron affinity, or it's going to absorb energy, which is the ionization energy, just depending on what the atom's going to do when it takes in that extra electron. Now, nonmetals. Nonmetals have very large affinities, large ionization energies. Okay? They want to gain electrons. They do it easily. So they're really, affinity is how much do you like it, right? So they really like to have a new atom. And ionization energy would be how hard it would be for somebody to take it away from you. Well, if they really like another one, they're not going to give it up very well. Metals, just the opposite. They have low ionization energy and low electron affinities. Okay, they will readily give up that electron. All right, so once again, on your chart, draw your arrows. Electron affinity increases as you go up, increases as you go to the right. Once again, we don't have any of these. Okay. And if you look at ptable.com, you'll see there's some other ones too. But for us, we're just going to keep up and to the right, getting stronger, higher electron affinities. Alright, so that is the end of this section.